The acceleration due to gravity is to be determined using the smart gate. The smart gate has two laser sources, as you can see, and on the opposite side, there are two sensors. In the first part of the lab, we will only use one laser source and one sensor. So that arrangement has to be made in the hardware setup. Also, the way you connect the smart sensor is using this rod, which goes into one part of this clamp, which can be tightened here. And the second part of that multi-clamp is attached to the A stand. Well, that is easy to figure out. So that's not described in the procedure, but this is the kind of arrangement that I would prefer you to use because it's the easiest. Here's the picket fence. The picket fence, as you can see, has transparent regions of the same width between opaque regions. And as the picket fence is dropped, so hold it like that, with the edge just above the smart gate, and then drop it freely. And please make sure that there is something to cushion its fall so that upon hitting the floor, the picket fence does not break. All right, so make sure that you drop it onto a pillow or something good enough to soften the impact. Let's go on to the hardware setup now. All right, so open the Pasco capstone and go to hardware setup. And do remember to turn on the smart sensor by pressing on that black power button there. And then go to hardware setup. It searches for the devices, finds the smart gate, click on that. All right, so left click where it says 1, 2 and click on picket fence. And that actually adds the picket fence. So picket fence, you can see down here, is added. And then click on the hardware setup, so that goes away. Click on the sensor data. Select measurement. Now you can select position, speed, or acceleration. First, let's pick position. And on the x-axis, it's time. Hold the picket fence between the sources and the sensors, and slightly above. Hit record, and do not wait for too long after you hit record, but hit record and then drop it and hit stop. That's a perfect fall. Okay, so that is free fall. Make sure that the picket fence does not hit any part of the smart gate or otherwise while you are dropping it. Okay. Now, in case it zooms out, here's the quickest way to bring it back. Scale axis to show all data. That's it. Actually go for quadratic fit. Take quadratic fit. I'm going to remove the linear part. And here you have the quadratic fit. Because you know that in free fall, the position depends on the square of the time. So that's why you will not get a straight line. So it's a quadratic fit in this case. Okay, so now after that, what we can do is we can just go with this run, click on the y-axis and pick speed instead of position, and get rid of this quadratic fit. We don't need that because, as you can see, now it's a straight line. So the graph between velocity and time or speed and time is a straight line. So what we need to do now is once again, in case it's not a perfect straight line, mine is, but in case yours is not, it's always good to go pick up the straight part, and mine is all straight, so I'm going to use maximum, and then go to this back again and pick the linear fit. And the slope of the speed time graph should give you the acceleration due to gravity, and it's 9.80 meter per second squared here. okay, that I'm getting. So that's the second part. And then once again we can go to, okay, let's remove this. So you got that second part. Go to the acceleration. Go to the acceleration time graph. Now this is highly zoomed in. Now this is highly zoomed in. To get the mean value of the acceleration, once again, pick this, highlight all of it, in fact, highlight all of those points. Try to get it. Yes. And then we can go to the statistics symbol that you see here. Because you have to be sure that you click on this, put the check mark on the mean, and then this is another switch. You see that? Unless you click it on, you won't see the mean. Do you see that? All right, so you got to make sure that's clicked on so you see the mean, which is that straight line, which is 9.77. Oh, okay, so technically this graph should have been a straight line, but this is highly zoomed in. That's why it looks completely off from a straight line, but that's okay. You get the mean value of the acceleration. Now to go to the second part, we need to go back to hardware setup, click between 1 and 2, and now we're going to pick Smart Gate double flag. Okay, Smart Gate double flag. That's what we're going to use now. Or add another page, add a page. We can go to the graph, pull the graph there, and let's see what we have. So double flags, these will show those caution symbols because it's no longer connected. No worries about that. Get the velocity between gates on the y-axis and time on the x-axis. And we got to do this one more time. So this time, again, I'm going to stand up, hold the picket fence in the right position, hit the record, drop it, and hit stop. There you go. And you get a perfect straight line. Hope so. Let's see. Yeah, you get a straight line. If you click on this again, it'll zoom in and you get a straight line. And this time you can again highlight it, or if it's a perfect straight line, you can go to the slope tool directly or the linear fit. So in this case, I've highlighted it. Go to this, take the linear and get the slope, which is the acceleration due to gravity. So that's how we do this. Now, as you can see from the document here, that you got to do this 4 times, and each time you got to get G from the velocity versus time graph, position versus time graph, and acceleration versus time graph. That is for a single beam. And then 4 times again with the double beam. So that is what you do. And here is you find the mean here, and you take those mean values and put it into these places that you have. And for each case, try to find the percentage error in G, I mean. Find the percentage error in the acceleration due to gravity. Okay, here is the rubric for the grade that you are going to get here. So make sure that you follow along. And if you have any questions, please reach out to me. Thank you.